Hello and welcome to today's masterclass with Dr. Stavros Pelekanos. My name is Holger Kast. I'm the head of global training education at TRI, and I'm leading you through this webinar today. I'm very excited to lead you through this webinar. The topic is today, it's one of three webinars and it's already the second one. The topic is raising the FP1 standard, abutment-free digital full arch dentistry. And so before I pass the word to Stavros, I would like to introduce you quite and quickly to the matrix system, why this abutment-free, the world's first digital abutment-free implant, is so perfect for FP1 and full arch cases. Since we have more than 8 patents included in the system, we are the only implant company in the world where it's possible to go directly into the inner connection of the implant. And this gives you a few main advantages. And there's 3 advantages of the system I want to point out. First of all, the immediacy. With an abutment-free implant system, with a digital implant, we can go absolutely time saving because we can place the implant, we can concentrate on the implant placement and then add a scan body and immediately have the position of the implant connection. And in our day, everything goes more and more fast. And with AI, we have already the possibility to design a crown in 2 minutes. And I know that Stavros is going to show one case, not only about full arches, also one case about the simplicity of scan and smile with this immediacy, which is a very big advantage of the system. Simplicity, I mean, is very fast explained because we do not have abutments. So we have much less components, which has also an impact on your savings of money because you don't need that much material products. So also you have a money saving, and time is also a saving. And this is very great. And personally spoken, the personalized biologics, the anatomic biologics design possibilities, because of designing the crowns already from implant level, gives me the biggest advantage of the system. Since I'm a dental technician, I really like this biologically emergence profiles. We have polished zirconia all the way down to the implant. There's no cement line for single crowns. We don't have to add a tie base. And this gives, after 6 years of matrix implants in the patient mouth, we see significantly biologically advantages of the tissue and also of the bone stability. So since the topic is today, no limits in full arch treatments, I would like to take the chance to explain you quickly how is it possible to have a full arch even with strong angulated placed implants without the compensation of the angulation with a multi-unit abutment. This is only possible because we can see here the square cut. This is on the left side, you can see a single crown. So we go in the inner connection. But for a full arch treatment, we just have this very wide 20 degrees internal connection which goes inside the implant, and this gives us a very thick base for full arches with an angulation in between the implants up to 50 degrees. And even then, when we have an aesthetic area, a little bit a tilt implant, the screw channel would look out of this prosthetic in the aesthetic zone. Therefore, we started 6 years ago with 20 degrees angulation possibilities. And I know that the chief developer, Sandro Venanzioni, is listening. And now we are, our developing team developed even a new possibility to angulate the screw channel up to 40 degrees. So even in a static zone, we do not need to compensate anything through a multi-unit abutment. There's 3 main points the matrix system allows you for the full arch treatments, which are really, really significantly better. And the first one is the abutment-free. We already talked about it, significantly less restorative height, which is also a topic, especially for FP1s. Quite sure Stavros will talk about this as well. In molar regions, when you have to add an abutment, sometimes it's a little bit a tricky problem with the occlusal height. And then no screw loosening and no breakage is something I just want to show you on pictures here. The first point again, emergence profile straight to the implant analog. In this case, it's a 3D printed temporary, immediate 3D printed temporary restoration. And here you can see a fully anatomic teeth almost. And imagine this is in polished zirconia. There's no aesthetic problems, and you have the full anatomic biologically advantages. The height of the implant position is one topic of FP1s. And here we have this always the abutment to connect, and this gives us a certain height. And when you do not have an abutment, as you see it here on the right side, the matrix system, you can really concentrate on the anatomic shape of the implant. And then you can see also on this picture these two different screws. Here's a prosthetic screw on multi-units comparing to this bolt screws from the TRI matrix system, which gives you the absolutely stable and a strong stability of and no screw loosening. So you can see that here a little bit better on an X-ray, which I just added here. This is an all-on-6. We have very strong screws comparing to this classical multi-unit, comparing to this classical multi-unit screws. We have significantly, you can see it here on the left side, significantly stronger screws. 35 newtons will hold this prosthetic in place, comparing to the small multi-unit screws with maximum 50 Newton centimeter screw retain. Okay, that was it almost from my side. But before I pass the word really now to Stavros, I would really like you to mark this as a date in your calendar, because we are going to have a nice course coming up. I know the Stavros is a really great skier, and we all love the mountains, and we will have a winter escape with Stavros Pelekanos, and where he explains much more detailed his 10 steps to immediate FP1 smiles. With us, a 2 days course in Grindelwald, and mark the time. And at the end of this presentation, I will even share with you a QR code, so you can get all the insights for this course coming up with Stavros. And now, Stavros, a very warm welcome from my side. I know you are sitting in Athens, where you did study to be an amazing dentist, and also you had your times in Freiburg in Germany, in the university where I'm born and raised, and also started to be a dental technician. And it's a very good pleasure that we have also in the future a connection with you and TRI, that we implement your knowledge into our future developings together. But now, please start sharing the screen and introduce yourself. I stop sharing my screen, and then Stavros, please introduce yourself, and I'm looking forward for a great presentation.
Thank you. Thank you very much, Holger. It's a great honor to be here today. And of course, I think the most interesting part of your presentation, of course, it's TRI, but I'm looking really forward to these 2 days in Grindelwald, where we will have some fun together. So let me share my screen, and just let me know.
Coming up, perfect.
If it's coming
perfectly.
So just a moment.
No problem.
Then...
By the way, you have always the chance to ask questions during Stavros' presentation. If you want to ask the question, just please write it in the box, in the questions box, and I will pass those questions later at the end of the presentation to Stavros. And if we do not have the time, we will make sure that you get an email with the answers to your questions. Okay. Maybe you can make it full screen. Yeah.
Is it full screen? Is it okay?
Perfect. Everything good.
So as you mentioned, speed is one thing, but I think we should talk about quality and biology first, because I think we are already fast enough in dentistry. We are doing things really very fast, but our main goal and our main protocol and aim should be quality. And I think here TRI has a really big potential in achieving quality work. Let's start with what did we learn from the past. So from the past, as you can see here, this is an older case of mine where we had tie bases, only one height. So basically like 0.5 or 1 millimeter. And then we didn't have any other chance to have a bigger, let's say, transmucosal contour. And I think this is a big bottleneck in implant dentistry. So for me, tie bases are really a bottleneck in implant dentistry. And the reason I really like to work to work with TRI is the opportunity that we have to avoid tie bases. So in the past, as you can see here, we have like three gaps. One was the mechanical gap between the implant and the abutment. Then the second gap was a cementation gap between the tie base and the zirconia or the material of our choice. And if we're choosing a cement retained restoration, then we have a third gap. So practically in the transmucosal contour, we had like three gaps. And as you can see here, when you have this cementation gap very close to the implant, then the problems are coming. And we know very well from University of Zurich and my Greek friend Alexis Ioannidis and the work from Zurich University together with my friend Ronnie Jung that after mechanical loading, this gap between the zirconia and the tie base is not always ideal. So there is always through thermal and mechanical loading affection of the cementation gap. And much more if we are using a third-party component, this result is becoming even worse. Then we have other problems with tie bases. Companies are now trying to fix it, to make better tie bases in terms of precision, height, fit, anti-rotational features. And still there is always a problem of the accuracy milling. And at the end, last but not least, we need to cement. We need to cement the tie base onto the material of choice, which is, again, another factor of error. Even some years ago, we tried to eliminate gaps by producing direct connection to implants through Atlantis, for example. But still, we had problems, a lot of fractures, a lot of, due mostly to the wrong way of designing the connection. So there's another study from a group of Zeiler. At that time, she was in Zurich, not in Geneva. So, of course, the type of connection significantly influenced the strength of the zirconia. And at that time, the connections that we had, they were not so good like the titanium connection. Even companies till today, I don't really understand why they are producing titanium bases that they are really like big and wide. For example, in case of if we want to create the transmucosal contour already from the deep zone or the transitional zone, then we have problems. Many times in my office, in my practice, I need to reduce tie bases, like in this example, for example, where I have two central incisors, because when we have, and then I had to do it manually. So when I have to create transmucosal contours from like create papillas to create a transmucosal contour or 4 or 5 millimeter, we need to have the correct deep zone. And the deep zone is very, very important. So unfortunately, companies don't pay attention on the prosthetics, and prosthodontics, as you know, is the boss. So many different attempts to make to produce abutments, but most of the time in the wrong way. So design must be guided by pros. So nowadays we have better hardwares and softwares. We have better implant macro and micro geometry. We have, of course, guided implant placement and the digital workflow, and the technology are advanced. The new trend on the implant design is like being narrow at the neck, and as you can see, some examples here. And why? Because we want to avoid actually compression on the cortical bone, and also not only the buccal and the palatal or lingual, but also the mesial and distal parts. So we call it, let's say, hybrid design of implants, and much more if we can already have the deep zone in a concave way, and one piece this would be the best. So like the TRI matrix, where we have the part of the deep zone already connected to the implant, which is like a soft tissue level implant, but going to the only for the deep zone. So in order to do that, we have to have a good connection, and the connection, especially when I'm talking for zirconia, it has to produce compressive stresses, and this is, let's say, the secret of the direct zirconia connection. And of course, we are a rough to the top implant and a good conical connection. We know that we have to place most of the time a little bit subcrestal. So having, let's say, a little bit subcrestal positioning, this is an immediate implant, and by having in one piece deep zone and one piece transmucosal component, which is permanently connected to the implant, we avoid compression in critical areas, buccally to our augmentation materials, and lingually, of course, on the bone. But not only that, but also mesial and distal, especially in the area where we want to preserve the papillas or boost the papilla, we need to have at least 2 millimeters of space. We know this already, the literature from Dennis Tarno and Perez. So nowadays we are measuring the distances between not from the implant level, but from the abutment level. So practically the numbers you see here are on the abutment level, and should be like 3 millimeters of tissue buccally of the implant, and 2 millimeters of tissue between the deep zone of the abutment and the neighboring tooth. For me, these are the most important numbers that you have to have in the aesthetic zone. And maybe some of you are familiar with our article that we published already with Yanis Vergoulis like a couple of years ago. It's almost 3 years ago, where we are talking about the deep zone, the traditional zone, and the cervical zone. So the deep zone, which is given by the transmucosal part of the abutment in TRI matrix implant, it's already given by the transmucosal part. So the deep zone is practically occupied by the implant collar. And this is very important because this is functioning like one-time abutment in the best version, let's say, which is no connection. So I will show you just 2 cases in the aesthetic zone, and then we will move to our main topic, which is full arch implant cases. So let me go a little bit further here. Yes. where these are immediate. I'm going to start with immediate implants. And in our case, as I told you, the deep zone is given already by the transmucosal part of the implant, which is already connected to the implant. So these are two premolars. Let's start a little bit with some cases. We are using, in this case, zirconia aesthetic prime. These are two older cases. And as you can see here, this is high poly zirconia on the transitional zone and the cervical zone. So this is the best thing you can do when you are having a soft tissue level implant and zirconia deep into the tissues. So in all of the time, we need to hand polish this part of zirconia. So in our article summarizing, we need like not more than 15 degrees of angulation in the deep zone, which is much less for TRI. Maximum 90 degrees in the transmucosal contour and less than 15 degrees in the transitional part. So what we need is to maintain the connective tissue on top of the rough surface of the implant. So by connecting and disconnecting abutments onto the implant level, what we are doing is disrupting this connective tissue adaptation, and we are moving epithelium much more deeper onto the implant. So just a nice video from my friend Nitzan Bichacho. Connection and disconnection on implant is always leading to soft tissue and apical soft tissue resorption. Much more, the screw can be also a factor. The gap between the screw and the abutment can always be a factor of microbes into the implant. So most of the time, the surface, this neck of the implant is supracrestal, but nothing wrong of placing also this part of the implant into the bone in cases where we don't have tissue, enough soft tissue height. And of course, it can be used immediate or late, and most of the time we can place immediately a prefabricated abutment. When I say prefabricated, is pre-milled or pre-3D printed. And this is something that we can do like in 2 minutes. The libraries here are given by TRI. So these are two molars, and the transmucosal contour is produced same day, same time with the implant placement. So in cases of immediate implant placement, we have again two options. Most of the time I go guided, so I navigate my implant. In this case, we extracted the first premolar and we placed a TRI matrix implant. Navigation is extremely important, very important in order to have the exact position of the implant. So now we have two options. Either we go for first option is we can scan and we can deliver a 3D printed crown in like let's say 15 or 20 minutes. And this can be done with a software that TRI has developed, which is like a software which is actually for dentists, not for technicians. I will show you maybe in in the next case. I will show you another two cases regarding immediate implants in the aesthetic zone. The second option is to already prefabricate a 3D printed flexed fit, we call it, where the tie base is not a titanium base. It's a 3D printed material. We are using usually either a strong 3D printed material, which is lately we're using the material from IDITE, which is an amazing material for immediate loading. And as you can see here, the flex fit, this base is moving, is very flexible. So we can place the implant and at the same time we can have the crown. This is the extraction, implant placement. And we screw it onto the implant. As you can see, it's flexible. Then we connect with some composite, flowable composite, and that's it. So in like really 40 minutes, we are really ready with the provisional immediate loading crown. So second option, and this is the last case I will show you in terms of single implants. This is a late implant placement. We have here a Maryland bridge on the number 12, 1, 2. So we do the planning. The planning usually we do in the Smile Cloud. And as you can see here, we are planning always the part of the implant which is rough, approximately 4.5 to 5 millimeter below the clinical crown. So the planning is done in advance. And now let's go to the surgery. So we remove the old Maryland bridge. This is a late implant placement. We clean the composite. We have a good soft tissue mesial and distal. Now, that's why I decided not to cut on the papillas. So what we do is we create only a punch. So we remove a part of the tissue that is related to the implant placement. So as you can see here, I'm punching out the tissue from where we have to remove, and then we have to pass through the implant. So we cut this part of tissue. I don't want to lose the papillas here because the papillas are already in a good position. Maybe we are missing some buccal soft tissue, but this is easy to do because we can do it through tunnel. So now guided implant placement, this is like 5 minutes procedure. We're using an open guide system, the SMOP here. And we are using a slow drilling protocol, grabbing the TRI matrix implant and positioning into the implant site. Final torque, as you can see here, are more than 30, more than 40. I'm close to 50 Newton per centimeter. Now, next thing is to take a digital impression. And second is to place a connective tissue graft. So first, we are doing with the prosthetics. Always we are dealing first with the prosto. So now we are scanning the implant. Then we are creating a punch, and we are in order to place a connective tissue graft. So until I have to say that the crown is ready in the time that I am doing the soft tissue graft. So this is really good because I spent some minutes in order to harvest the graft, to make the tunnel here, as you can see, and to boost the biotype, the soft tissue on the buccal part of the implants. I'm harvesting a small piece of connective tissue graft from the palate. I'm gonna play the video a little bit faster here because this is something that everybody is doing. So the tissue is not more than 4 by 7 millimeter. We don't need too much connective tissue. And then we are placing the connective tissue. And in the meanwhile, Sandro is, because we did this case with Sandro, maybe Sandro, you remember, Sandro is producing in the AI software of TRI extremely fast. Like I put the time and he needed only like 1-2 minutes to make the digital crown. This is the suturing. We always like to suture the soft tissue graft in front of the deep zone of the abutment. So that's why we don't like to suture the graft, let's say, very deep, as you can see here. So just a small video to show you the workflow that Sandro did. Extremely fast, taking the impression. And through AI, he generated a tooth, copy paste from the contralateral side, so the tooth of 22, and then positioning the implant, the crown. So everything was done like in I would say 40 minutes. So this is 10 days after loading. Nice wound healing also for the soft tissue, as you can see here. And this is also 10 days after. And as you can see, the papillas we didn't touch. So the papillas were in place, and this is after 3 months. And now it's very easy to produce the final crown. The case is still ongoing. So let's go to the full arch restorations. As you already know, maybe some of you have seen a lecture of mine, we have created the 10 steps. So the 10 steps are just because on a single implant is, let's say, maybe 1 or 2 people involved. But when we are talking about full arches, then we are talking about a lot of people that are involved. So this can be the prosthodontist, the the periodontist, the guy who is placing the implant, the designer who is doing the guides. In our case, we have another designer for the final design, and another designer for the 3D printed for the guided surgery. So in general, there was always a miscommunication. There was always some steps that we were not really thinking of. And that's why we decided to create, let's say, a 10-step protocol. When we're talking about full arch cases, and this is a case that we did in the lower jaw, we have a terminal dentition here. So as you can see here, so in this case, we did the lowers. This was the situation of this lady. She was wearing removable prosthesis. She was totally unhappy. The teeth were small and starting to move. So there was, I think, not better option here to go for full arch immediate implant placement. So a part of the steps is the planning. And as you will see, we invest a lot of time in the planning. So we are planning the implants in a very accurate position. And what we do is we want to be with the time we spend with the patient is usually not more than 1.5, 2 hours, but we spend a lot of time for planning. So usually it's like 80% of our cases are planning and 20% are working, executing. In the past, we had 20% planning and 80% working on the patient. So implants are planted in the exact position, and we have now 2 options. Either we deliver the final, the provisional at the same day, or we scan the patient and we deliver the implant, the work, the provisional work, the immediate loading late in the afternoon, same day, or the next day. What we do until now is delivering same day, same time the work. And what we do is delivering the final work of the implant. And here you can see the flex fit, which is a 3D printed bridge where we are using in order to make the immediate loading, as you can see here. And we are, through the flexibility of this construction, we are able to screw in and to make the immediate loading. Let's see step by step the surgery, so you will understand. Here we have the flex fit material. So you see that it's moving. We decided to go for stackable guides. So we have the base, and then we have, we always, in the mandible, we use 5 pins, and also in the maxilla. 3 pins are always buccally, and 2 pins are always palatarily or lingual. So the pins also, they have to be not parallel to each other, but to have like an angulation of 40-45 degrees is possible. So the fit between the guys are very important. Here you see the relationship, the base with the implant guide. And once we start the case, the surgery, the base is not removed until the end. Here is the stack of the provisional together with the base. So what we want to do is deliver the final design from day one, because if you want to have an FP1 restoration where with nice papillas, you need to be able to deliver the final design on day one, which means that we need to plan accordingly. We need to plan, we need to have the VEX model, where I will explain you in the next case how we do it and why we need it. These are the 3 buccal pins. And now you will see the 2 lingual. So once everything is stabilized with the 5 pins, this is our protocol. We remove the upper part of the guide, and then we remove the teeth, of course. We try to keep some teeth if possible in order to have one more stabilization for the guide, but this is not always possible. So here we usually make a small flap. We don't need to raise a big flap. Now it's time for the implant placement. Again, during the implant placement, we never remove the carriers because we want the whole thing to be stable. We are placing matrix implants. Remove some bone in case, because we want to do an FP1, so we need to be exactly accurate. Here is the prosthetic guide with a flex fit construction. Now we remove from the mouth. We are fine. We are light curing also from the downside. And like in a very short time, usually this is not more than 2 hours. Sometimes it's 90 minutes, sometimes it's 2 hours. The goal is to deliver the final designs. That's why you see we are really predicting the final design on day one, because I want my soft tissue to heal around my design. I don't want to change designs. And this is the goal in all of my FP1 or FP2 cases. Of course, we place some sutures also for the small holes that we created for the pins. So, and this is how the patient leave the office. So this is something that we do in all of our FP1 cases. So Again, this is the base, the 5 pins, implant placement, final delivery. So this is like 2 hours later. So, and this is like maybe, I think, 8 weeks after implant placement. And you see the nice soft tissue healing of this case. So something that many people are asking me what we are using for scanning. Passivit is a big topic. We need to talk maybe I don't know how many hours or days. We don't really have this much time, so much time. To obtain passive fit, especially where we are dealing with full arch zirconia, we need to be extremely accurate. So in terms of scanner, I would say that according to the literature and what we have already tried a lot, when we're talking about scanning scan bodies, we're using the Lumina scanner from Itero, which is when it comes for immediate loading, or let's say a PMMA material or a material that is a little bit flexible, it's extremely accurate. So the first option is photogrammetry. So if I have to choose, first option is photogrammetry, and we are using the PIC system. And the second option, if we need to scan, we do it with Itero. So just to summarize the 10 steps with another case, it's already published this year together with my friend Ben Sistankov, Emil Bobev, and David Noret from Belgium. So the question is what we do, why we do it, and most important is how we do it. We already published this a few months ago, and together also with Sofia Gika and Panagiotis Dovas from our team here in Athens. So just to step-by-step protocol is step number 1. This is a patient that came to our offices, data acquisition. Data acquisition means intraoral scannings, IOS, as you can see here, pictures, X-rays, CBCT. We always use dynamic recording of the lower jaw. We are using the mojo. So we are doing the motion of the patient plus, last but not least, the face. So for me, the more data you accumulate, the more exact is the treatment plan and the execution. So if we want to deliver a final design from day one, when we are doing the surgery, we need to be extremely accurate. I don't want to spend too much time when I will do the surgery, which means I don't want to have any interference. I want to have an occlusion which maybe I don't spend more than 10 minutes. You know, in the past, immediate loading, when we were doing immediate loading procedures, we were spending like 2 hours for occlusion. Patient was biting and he was biting like this. And then we need to spend, I don't know how much time for occlusion. Nowadays, 5 minutes and the whole workflow is finished of occlusal adjustment, because we do a lot of recordings. So again, pictures, step number 1, intraoral scannings, X-rays, motion, face. So step number 2 is smile design. So why we do the 2D smile design? The 2D smile design we do in order to define the incisal edge position, the incisal curve, the papilla proportion, and the tooth proportions. Very, very important. At the same time, AI has, especially SmileCloud, has a very good feature. We call it the Yes video. For those you want to learn a little bit about SmileCloud, in September, we have it in Timisoara with Florin Kofar, a very nice event explaining all the features of treatment planning and SmileCloud. So this is like the first approval of the patient. These are just pictures in motion. It's not a video. So this is just for approval of the patient. And at the same time, we define, as we say, the incisal curve and the tooth proportions. So step number 3 is merging the files. So we are merging the face, the upper STL, the lower STL, the CBCT, and the motion. And in that way, we are creating the digital avatar of the patient. So now it's the time for the doctor, for the dentist, to take decision about, first of all, to make a diagnosis and take decision about the VDO, the centric relation, and the treatment plan. So now, step number 3 is the time to do all this. Now it's a time for the dentist to do the diagnosis and the treatment plan. And of course, step number 4 is the conversion from 2D to 3D. Now, this is something very important because the 3D design should be very accurate. Because we have to position the teeth, and this is something that is done easily, especially when you do the segmentation in SmileCloud, where we are having moving teeth in relation to the bone and the soft tissue. So this is something like a mind game, I would say. And of course, at the same time you move a tooth, you can see same time on the patient's face. So this is very important. And now it's really time, when you have segmented everything and we are placing the final design, this is the time for you to decide about FP1, FP2, or FP3 restoration. In this case, you see on the left the initial situation, and on the right side, not here. Here is the segmentation and the VEX model, which is a step 5. And then what is the VEX model? The VEX model is a model where we have the negative reproduction of the soft tissue and the roots without the teeth. Why is that important? This is important in order to place the design in the correct position. Not only the design, but also the components, because we need to place design and components at the same time. So what you see in white is the final design of the patient. And as you can see, an important step, which is the step 6, which is the 3D final design, we are predicting the remodeling as well. So how we predict the remodeling? By going 5 millimeter deeper, checking the width of the tissue that we have. And in that case, we need to place the final design like at least 1 millimeter more palatal and 1 millimeter deeper, let's say. And as you can see on the right side of the screen, the white lines are in the VEX model, which is the design is in the VEX model. Of course, we can visualize implants. In this case, I think we plant 7 implants. And as you can see here, the transmucosal part in the deep zone, which is in the matrix implants, the part which is polished, is designed in the VEX model, which is very important. So step number 8 and 9 is the design of the 3D printed guides and the milling of the 3D printed guides. It can be stackable or not stackable. And here, step number 10 is the actual milling and 3D printing of the final design and restoration. So here we see the Vensi just opened the door. So here we see some parts of the surgery. So again, stackable guides, I will go, and this is the flex fit. I will have to run maybe a little bit the video. So now we start the surgery. We are placing first the pins, again, the same way, 3 pins in the palatal, in the buccal part, and 2 in the palatal. We always do the same, all of our cases are in the same way. So extraction of the teeth, then we are placing, this is the implant guide, positioning the implants. So TRI matrix implants. All of them had more than 30, as I remember, more than 30 Newton per centimeter. And now it's time to place the flex fit. So this is the flex fit, which is stacked on the guide. So now we are connecting these flexible bases, let's say, they're not tie bases, together with the design with some flowable composite materials. It's the same way like if we had titanium bases. So light cure and some images of the case. This is the base with the implant with the 5 pins, the immediate loading procedure. I'm not using the scan bridge actually. Like to use, as I said, photogrammetry. So this is or the Lumina scanner if I have one of these two options when I want to go digital. This is like 120 minutes later, almost 2 hours, and this is after 10 days. You see a very nice healing around our final design. And this is after 3 months. Now, of course, we always deliver a second part of a prototype, let's say. And here, as you can see, this is the photogrammetry that we used in this case. So this is the final emergence profile, normal scanning, second scanning with the implant scan analogs and the photogrammetry that we use from PIC, the PIC, extraoral photogrammetry. And this is for me, the best verification for passive fit is having a stone jig. So in this case, because we wanted to have a direct zirconia, no titanium, we created a stone jig. So for me, the stone jig is the most accurate because if this jig is breaking in the mouth, it means that it's not passive. So here you can see the stone jig. And the final work, we use eye zirconia, which is zirconia which is from Zirconsan 1600 megapascal. And on top of it, we used as a fifth generation zirconia monolithic, which is more translucent. And this is the final work of the patient. Time flies. So summarizing the steps. Step number 1 is data acquisition. Step number 2 is the 2D smile design. Step number 3 is the merging of the files and the segmentation. Step number 4, this conversion of 2D into 3D design. Step number 5 is the VEX model, as we already mentioned. Step number 6 is the 3D final design. Step number 7 is the implant software. Can be SMOP, soft, or whatever you want to use. Step number 8 is the final check. Step number 9 is the virtual guide design, and step number 10 is the actual milling or 3D printing. So if you want to learn more, we have one option that we are using. We will do the 10 steps protocol in October in our ADEA together with Emil Bobev and with a live surgery. But as already Holger mentioned, the main event will be next January 28, 29. And this will be a great opportunity to ski together and learn together. This is my son skiing here, as you can see, off-piste at the age of 5. So if you want to compete with my son, you are welcome to come. And I would like to thank you for your kind attention.
Thank you very much, Stavros. Perfect. Thank you so much. I would like to compete with your son.
Nobody wants to compete with my son.
Yeah, I saw quite a lot of videos, and I think he does really a nice job as you do with your dentistry. And it's actually really a pleasure to see this evolution with this digital implant from single crown to full arch treatments. And it's for me also, I'm very happy to be a part of this whole journey to go fully digital. We have now a few minutes more because Stavros told me he has to jump from this webinar straight into the surgical room again. But since we promised to pass at least some questions, and we will pass the questions later on via email if we cannot answer all of them. But let me open quickly here the questions field. There's quite some questions in there. Which composite is specifically used? I think that was asked when you were doing the teeth to go, that flex fit combination. Maybe I can quickly even answer this. This is really amazing what we see with this flex fit, because we 3D print the temporary with the cylinders. And all of you who already do full arches, when you have to cut the titanium cylinder in the patient's mouth and get everything ready, this is really not so nice. And here we have like the same. We have PMMA based materials, and then when we have a composite, also PMMA based light curing, we get even a chemical bonding in this moment, which is nice. But you maybe can answer which composite you were using for this case. Can you remember, or do you?
I don't remember the name, but really, it's not so important.
It's not so important, exactly.
Not so important actually to tell you the truth, because okay,
do you want to share?
Stop sharing just a moment.
I will share mine.
Now I see you. It's any flowable composite, let's say, with high particles, needs to be also strong, but I don't remember now the name that we are using. Yeah,
we just see that is the big advantage of this chemical bonding as well. And this way of flex fit or teeth to go, we need to think and consider, as Stavros told, that we had changed the 3D print the temporary to a final milled version later on. So then there was another question, which was more on, that was from Henry, which was more on the connection of the implant itself. And here, Henry, I really tell you that I think I share some links with you to that you understand the implant connection of the matrix connection better. We have very lots of science, and that you can go also yourself. And if you want to share the last slide of mine is a QR code, we can give you specifically more information information about really the matrix connection, how does it work, and so on. And then there was another question: how do you do the photogrammetry just with the scan bodies, or you have specific scan bodies for this step?
Yeah, always when you do photogrammetry, we do one scan of the soft tissue and the scan bodies of the company, and then we are using a special scan flags, which you connect to the implants, and then we have a second file with the scan flags with the library of the photogrammetry, which we are connecting in the software together with the library and the scans that we did conventionally.
Yeah, here also it's as simple as we want to be at TRI. With the matrix system, we have developed so-called adapters. So these adapters have the connection into the implant, and then they have a design of the most common scan flags from different photogrammetry providers. And this connection allows you to use most of the time already your existing scan flags. It doesn't matter with which system you work, and we are already working in combination with the main photogrammetry providers. So this is something we can always individually, when you would decide to work with us, we have already the adapters, and it's not a lot of more costs for you to use photogrammetry with the matrix system. I know you really short on time. That's why the last question: the flex fit of the FP1, is the wax up printed? That's a good question. Since I saw bit was ready before surgery started. Maybe you can explain this a little bit, how we did that.
The flex fit of the FP1 is 3D printed, actually. The design of the flex fit is actually not, unfortunately, not of the dental software. It's something that actually you have to send to TRI, and they design for you the flex fit connection. But the material is 3D printed. So this is from my side. Maybe Holger, you can.
Yeah, it's like this. You have we create the flex fit based on the virtual position of the guided implants later on. So the virtual position, we have it, and this wax up you have to send to TRI, and there's a special software which we developed. This is our patent, which we developed, and then we recreate this wax up, and we send you back an STL file which you can 3D print yourself. So since we are already over the time, and I really know, Stavros, that you have to go back to the surgery, I would just like share two seconds, and this is here. If you are ready to get abutment-free, you should for sure now take your phone out and take a QR code, so we can get in touch with you. We can get you individual more information about the system. You will get also the information of the January happening in Grindelwald with Stavros Pelekanos. Please take a QR code, a snapshot of it right now, and sign up, and you get much more information about the matrix implant system. And last but not least, the last slide I want to share is this one, because we have also the third part of our masterclass about FP1s with matrix system, fully digitally, with Dr. Girdas from Lithuania. Which will take place on October the 15th at 3 p.m. again. And in this moment, I really would like to say thank you very much again, Stavros. I hope we see us soon, and thank you for a kind presentation, and hope you have a good surgery right now.
Thank you so much, Holger, and see you soon, guys.
Okay, bye. See you. Bye-bye.